OK, so I'm going to give you a inspiration for a practical development and continuous integration workflow. It's very similar to the one that I've used both on my own work and projects that I've done with colleagues. And once you get into the groove of using a CI workflow like this, you'll find that it's really enjoyable to work. It's like being in a cockpit where you've got indicators all over you, and you just know that if something goes wrong, it won't be long before you're told about it. And it really changes your perspective on the process of writing code. It becomes, instead of a process where you do some work and then you wait a while and you eventually get feedback, it's a process where you're getting feedback all the time. And the level of awareness of how close you get to your own code, I mean, it sounds a little creepy to say that, but it's actually very cool. So before you start, what do you need to have? You need a self-contained and automated workflow, hence our robot friend. So what does self-contained mean? It means that there's a small number of command line tasks that essentially can start from absolutely nothing and get your app to the point where it could service requests. And a nice thing about the Rails framework, in my opinion, is that it makes it easy to do that, which makes it in turn play very nice with CI. So a typical set of such lines might go like this. Starting out from an environment where the only thing that you know for sure is that you have checked out a copy of the repo, if you run bundle install, if you have a complete gem file, bundle install should make sure that the right Ruby version is in place and all of the gems that your app depends on are properly installed. If you run the db setup and db test prepare tasks, db setup will load the latest version of the schema. Remember that every time you do a database migration, it regenerates the schema file, which can be used to essentially populate a database on demand with that schema. So the setup task also runs the seed task. So if you have seed data, like configuration data or other data that just has to be in the database for anything to happen, db setup will take care of running that as well. db test prepare will make sure that that same schema is copied over to the test database, so that if you're about to start a testing run, your tests are going to run against the same schema as production. And then finally, if you just run bundle exec rspec and bundle exec cucumber, they should be able to find all of your specs in the spec directory, your cucumber scenarios in the features directory, and they should run all the tests. And because the tests are self-checking, the tests know if they passed or failed. Ideally, in the world that I come from, I also care a lot about test coverage. So we gave instructions in the book and elsewhere about how to turn on simple cov so that every time you're running your tests, you're also collecting coverage information. So basically, there's no implicit dependencies, right? This set of commands, or whatever it might be for your project, is 100% of the work that you have to do before the app is ready to be stood up on a server and start accepting requests from the outside world. It's completely self-contained. And in essence, this is what happens in a CI environment, right? A CI environment starts out with a blank machine that has only your app checked out. And you need to provide the CI environment a relatively short list of tasks that by the end of them, all of your tests will have been run and all of the coverage and pass-fail information will be available to report. So in the scenario, the flow that I use a lot, the schematic kind of looks like this. And I should point out that where I use a logo, it is not because I have any connection to them. They're for education purposes only, and they make the slide look nice. So my world always begins with doing my pushes to GitHub. I might be pushing master, or I might be just pushing a branch. A thing people don't often realize is that as you're developing a feature on a branch, you can be doing all of your CI on that branch as well. You just got to make sure that when you push to GitHub, you're pushing your branch. So whatever it is you're pushing would automatically, in my case, trigger code climate to check out that latest commit, which might be on a branch, and let me know if any of my code metrics have declined. It would also trigger a run on continuous integration. I've used both Travis and Semaphore at different times, but again, you can configure them to access your repo automatically anytime you do a push, to automatically check out the repo and run all of your tests. And we'll show an example travis.yaml file in a moment. If you've done your integrations, you also know that Code Climate and Travis can both report back to GitHub in the form of the little badge icon. So a common trick that you see in a lot of GitHub repos, and which we recommend for your projects, is in your readme.md, which is effectively the splash page for your repo, have your Code Climate badge, have the Travis CI tester passing badge, and maybe even have a coverage badge. There's an integration that Travis and Code Climate or coveralls in CodeClimate. There's various services that collect testing coverage information. CodeClimate can actually pull from those services and report it as part of the CodeClimate badge. So you can do that. You're also using Pivotal Tracker to track what your reporting is. And there's a tracker integration such that if you put a particular notation in a commit message for a commit that closes out a feature, GitHub will automatically update your tracker saying that you delivered the feature or that the feature was pushed to production. There's a number of different messages that you can get. Finally, you're usually deploying. Most of the time, somebody is deploying from their repo by doing git push Heroku master. But if you're ambitious, you can turn on automatic deployment, where every time you push to GitHub, GitHub will automatically force a deploy to Heroku with the branch that you just pushed. So this part of the workflow, you get into a scenario where from the moment that you've pushed code to GitHub, within a few minutes, you have immediate feedback on, did all of the other integration tests pass that are not part of your flow? Did you affect the code quality of the code base adversely in one way or the other? On top of all this, though, you want to have team communication about what's happening. And this is where I think a lot of teams have started to use Slack. One of the nicest things about Slack for programmers is how easy it is, relatively, to integrate it with these other environments. So for example, not only do you have information being collected through CodeClimate and through coverage tools and so on, you can have CodeClimate automatically notify you by posting to your Slack group if a particular push just made the code quality go down. At a startup that I'm working with, we actually take these Slack messages pretty seriously. And if there's actually a threshold that you can set on how much the code quality has to decrease before it will trigger an alert in your Slack channel. So when we get those alerts, they're usually pretty serious. And in fact, sometimes someone will even follow up saying, don't worry about it. It's just my topic branch. I'm going to clean it up as soon as I get all my tests passing. You can get Travis to Slack you if some of your tests failed so that you know who broke the build. You can get GitHub to Slack you when somebody has done a merge or has done a push on master to the repo. You can get Pivotal Tracker to Slack you when somebody starts working on a story or delivers a story, when a story goes through various state changes. And you can even get Heroku to Slack you. This is a really useful one if something goes wrong with your app in production and you're not there to see it. So for example, there's a number of different Heroku add-ons that will catch runtime exceptions in your app that are not otherwise handled. I've used one called Rollbar, but there are a few different ones. And they can also be configured. Not only do they capture the data and give you a nice stack trace, they give you a lot of the debugging help that if you were in the development environment, you would take it for granted. But if you're in the production environment and your app gives that Heroku message of something went wrong, you really would like some better information to help you debug it. So using one of these add-ons not only gives you that information, but also you can trigger it to report to your Slack channel when that happens. And that's usually a big deal, because those failures tend to be things that are visible to the customer or to the end user. So you'd want to know about them right away. One question that I answered recently with respect to this workflow is, how does managing API keys figure into all this? If your app is doing external integrations with Stripe or Google or whatever, you don't want to publish your developer key or your API key by making it part of a file that's checked into a repo. There's a number of ways to deal with this issue, but I'll tell you the way that I have successfully done it. Is first of all, get a good encryption package, like PGP for pretty good privacy, or the GNU implementation of it, GPG for GNU Privacy Guard. And use the gem called Figaro, which has been out for a while. Figaro dries out your application secrets, like API keys and things like that, by letting you put them all into a single file, application.yaml. But don't version that file. Instead, encrypt that file with a key that only you and your teammates know, and that is a difficult-to-guess key that you don't write down, et cetera, et cetera. That file can be versioned if you trust that your key is good enough. Here's an example command line for actually encrypting the file. In both Heroku's deployment environment and in your CI environments, they will let you set environment variables. Sometimes they're called settings on Heroku, but really what they are is Unix environment variables. So then you copy your secret encryption key as an environment variable into Heroku and your CI environment. And that assures that even if someone else manages to get into your Heroku or CI account, they won't reveal the values of those variables. So once you've uploaded the variables, they are no longer visible, but they're accessible to the running program. So in your CI script or in your deployment script, you essentially include an additional command that will decrypt the application secrets file in place, before your test run or before the app gets stood up. So this is one way to solve this problem. And the way a typical CI script might look, and if you're using Travis, the way you do this is you create a file called .travis.yaml that essentially contains a step-by-step process of how to set up the environment for my app before my test run, how to run my tests, and if there's any cleanup that you have to do after the tests are run. So a typical before script might be something like this, where you've set the environment variable in Travis CI itself so that you can decrypt the application secrets file. Then you run these bundle commands to make sure that the right gems are installed for your app. The actual CI consists of just making sure that all of your RSpec and Cucumber tests run. If you've turned on coverage, that will also collect coverage information. And if you're super paranoid, the after script will delete the raw unencoded application.yaml file from CI just in case prying eyes come around. So this is a workflow that I've used with some success. It doesn't take long to set it up. And once you've set it up, you'll find that you have a nice 360-degree view, not only of the feedback that you're getting from these different services, but you can connect them to your Slack channel and have your whole team get feedback on them as well.